In 1977, America's railroads scoffed at an unthinkable offer. A brand new locomotive so affordable they believed it had to be junk. The industry's giants, led by Locomotive division, and convinced that price signaled quality, flat out dismissed the GE B23-7, calling it too cheap to trust with their multi-million-dollar fleets. But within a few short years, the same machine they rejected would outlast and outperform its expensive rivals, rewriting everything railroads thought they knew about reliability and value. How did a bargain locomotive become a legend, and why did nearly every expert get it so wrong? The answer starts with understanding the fierce skepticism that shaped an entire industry. EMD's dominance over the American locomotive market in the late 1970s was absolute. Nearly 7 out of every 10 new diesel locomotives delivered to United States railroads came from the Locomotive division of General Motors. Their engines powered the fleets of industry giants, Union Pacific, Burlington Northern, Southern Pacific, Conrail, and Santa Fe, forming the backbone of mainline freight across the continent. For railroad executives, EMD's name stood for reliability, proven performance, and a kind of mechanical pedigree that had shaped operations for decades. Industry analysts of the period described EMD's grip as a near monopoly in trade journals and annual reports. From 1975 to 1979, market share tables show EMD consistently holding around 70% of all new locomotive orders, leaving GE and other contenders to split the remaining third. EMD's GP38-2 and SD42 models became standard equipment, not just for their horsepower, but for a reputation built on years of service without surprises. Railroads invested millions in training, spare parts inventories, and shop tooling tailored to EMD's designs. Mechanics in roundhouses from Chicago to Houston could swap out a traction motor or troubleshoot an electrical fault on a GP38-2 in their sleep. Loyalty ran deep. Purchasing committees weighed not just price or horsepower, but the comfort of decades-long relationships. EMD's sales teams could point to entire rosters built around their engines, and to maintenance records that reassured even the most cautious fleet manager. For many railroads, buying EMD was less a decision and more a tradition, one that promised stability in a time when freight volumes were unpredictable and regulatory pressures were mounting. General Electric, by comparison, occupied the role of challenger. Their Universal Series had chipped away at EMD's lead through the 1960s and early 1970s, but never managed to unseat the king. GE's offerings were often seen as experimental, sometimes plagued by teething problems or unfamiliar systems. While the company had proven it could build powerful locomotives, it had not yet convinced the industry that it could deliver the same bulletproof reliability at scale. The numbers told a clear story. In 1978, EMD shipped over 1,200 new locomotives in North America. GE managed less than 400. For railroad boards reviewing capital budgets, the safe bet was obvious. EMD's dominance shaped not just what railroads bought, but how they thought about value, risk, and the very meaning of quality in heavy machinery. This mindset would soon be put to the test by a machine that broke every expectation about what a locomotive should cost and what it could deliver. Price, for railroad procurement officers in the late 1970s, was never just a number. It was a signal, a shorthand for trust, durability, and the kind of backup that kept freight moving through blizzards and heat waves. In a business where a single locomotive breakdown could halt a mile-long train, the safest bet always seemed to be the most expensive. EMD's invoices ran high, but so did their reputation. For purchasing committees, a higher sticker price felt like a kind of insurance. The logic ran deep: if a locomotive cost less, something vital must have been left out. Procurement memos from the era, cited in trade journals like Railway Age, reveal a consistent pattern. Officers flagged any bid that undercut EMD by a wide margin. One 1978 industry survey quoted a purchasing director from a major Western railroad who said they could not afford to gamble on a bargain when their entire network depended on uptime. Lower bids from GE raised suspicions of hidden flaws, whether in materials, assembly, or after-sale support. The prevailing wisdom held that quality had a price, and anything below that threshold was a risk. This was not just about mechanical reliability. It was about the ecosystem that surrounded every locomotive. Expensive units came with comprehensive training programs, established parts networks, and decades of accumulated expertise. EMD's higher price tags seemed to guarantee not just a machine, but a full-service relationship. GE's offer, by contrast, looked almost too straightforward. The B23-7's $500,000 price tag, well below the $650,000 or more for an EMD GP38-2, set off alarms. Procurement teams worried that savings up front would mean headaches later, from unexpected repairs to parts shortages. Trade press coverage amplified these anxieties. Editorials warned that unproven economies could backfire, especially on mainline power. Letters to the editor in Modern Railroads and Railway Age debated whether a lower purchase price really factored in the true cost of ownership. Industry consultants advised railroads to stick with the familiar, even if it meant paying a premium. Behind closed doors, some procurement officers even argued that buying the cheapest option could damage their own credibility if problems surfaced. In this climate, GE faced an uphill battle. The B23-7 was not just competing on horsepower or fuel economy, it was fighting a deeply rooted belief system. For many in the industry, the idea that a less expensive locomotive could be just as reliable as the market leader seemed almost heretical. The safe move was to pay more and sleep better at night. Anything else felt like an unnecessary gamble with millions of dollars and reputations on the line. GE's engineering team approached the B23-7 project with a single guiding principle: eliminate anything that didn't contribute directly to reliability or ease of maintenance. At its core, the B23-7 was a 4-axle road switcher riding on 2-axle trucks front and rear, what railroaders called a BB wheel arrangement. The engine at the heart of the machine was GE's FDL-12, a 12-cylinder 4-cycle diesel producing 2,250 horsepower. This prime mover was already proven in earlier models, but here it was paired with a stripped-down supporting cast. The locomotive's electrical system was a study in restraint. Unlike competitors that leaned into complex modular electronics, GE's designers favored standardized wiring and components that could be serviced by any electrician familiar with basic industrial systems. One of the most consequential decisions was to abandon the aluminum wiring used in earlier Universal Series locomotives. Aluminum, though lighter and cheaper, had plagued maintenance crews with corrosion and connection failures. For the B23-7, every conductor was copper, a choice that cost more up front, but paid off in long-term copper reliability. Shop crews found fewer shorts, fewer burned terminals, and far less time spent tracking down elusive electrical gremlins. Mechanically, the B23-7 was just as direct. Traction motor blowers and radiator fans were driven by mechanical linkages, not by a web of sensitive electronics. The 4 GE 702 traction motors, one for each axle, delivered a continuous tractive effort of just over 60,000 pounds at low speeds, enough to move heavy freight without straining the machinery. For the frame, GE extended the length by 2 feet compared to its predecessor, the U23B, creating what crews called porches at each end. This extra space made it easier to access components for inspection and repair, and gave the locomotive a distinctive profile. The fuel tank capacity ranged from 2,150 to nearly 3,000 gallons, depending on the railroad's specification, and the locomotive's weight hovered between 253,000 and 268,000 pounds. Dynamic braking came standard, providing extra stopping power on long grades. Every major system was designed for accessibility. Oil filters, air compressors, and cooling equipment could be reached in minutes, not hours. The B23-7's cab was intentionally Spartan. Controls were laid out for function, not flash. There were no experimental automation systems, no advanced diagnostics, and no unnecessary creature comforts. Instead, GE focused on what would keep the locomotive running day after day: robust switches, reliable gauges, and a wiring diagram that could be followed without a degree in electrical engineering. This philosophy extended to the locomotive's external features. The walkway height was increased in later production runs for better clearance, and the underframe was thickened to handle years of pounding service. For railroads, every design choice meant one less thing to break, one less part to special order, and one more day the locomotive could be out earning revenue. The result was a machine that looked plain on the surface, but underneath, every decision had been made with an eye toward reliability and serviceability. In a market obsessed with bells and whistles, GE's engineers bet that simplicity could be its own kind of innovation. Every moving part on a locomotive is a potential failure point. For the engineers behind the GE B23-7, this was not theory. It was the blueprint for every design decision. Their approach started with a simple question: what can be removed, simplified, or standardized without sacrificing the machine's ability to haul freight day after day? Mapping out failure modes was the first step. GE's reliability team poured over years of shop reports and incident logs from their earlier Universal series. Electrical issues topped the list. Aluminum wiring, chosen to save weight and cost, had turned into a maintenance headache, prone to corrosion, loose connections, and heat damage. For the B23-7, copper became the standard for every conductor. It was heavier and more expensive, but crews immediately noticed the difference. Terminals stayed tight, connections stayed clean, and mysterious shorts became rare. The extra investment upfront paid off in hours, saved on troubleshooting and repairs. Mechanical auxiliaries followed the same logic. Instead of relying on complex electronic controls for cooling fans and traction motor blowers, GE used direct mechanical linkages wherever possible. This meant fewer relays, fewer circuit boards, and fewer surprises when a train was miles from the nearest shop. If a fan belt wore out, any mechanic with basic tools could replace it in minutes. The same philosophy extended to the traction motors. 4 GE 722 units, each one a proven workhorse built to be swapped out quickly if needed. Standardization was the watchword. Parts interchangeability became a cornerstone of the B23-7's reliability. Wherever possible, GE specified components that were already common across their -7 line, or even shared with earlier models. Air compressors, oil filters, and brake components could be stocked in bulk, used across multiple types of locomotives, and sourced from established suppliers. This cut down on the need for specialized inventories and reduced the risk of a locomotive sitting idle, while a rare part was shipped from halfway across the country. Even the frame and underbody reflected this focus. The extended underframe with porches at each end was not just about looks. It gave shop crews more room to access vital systems, reducing the time and effort required for routine inspections or emergency repairs. Walkways were raised in later production runs not for aesthetics but to improve clearance and safety for anyone working on the locomotive in the field. Access and safety mattered. By reducing the number of unique parts and keeping systems as mechanical as possible, GE's team slashed the number of things that could go wrong. Every choice was a hedge against breakdowns, a way to keep trains moving and maintenance teams focused on what mattered most. The result was a locomotive that did not just look reliable on paper, but proved it, day after day, across thousands of miles of track. Seaboard Coastline took a gamble that most of the industry would not touch. In 1978, their procurement team placed an order for dozens of GE B23-7s, including a unique batch known as the BQ23-7, built with an extended cab for crew comfort as cabooses faded from freight service. The decision drew skepticism from peers, but Seaboard's mechanical officers saw something others missed: a chance to simplify their roster and cut down on chronic shop headaches. Within the first year and a half, stacks of maintenance logs told a quiet story. Failures that once clogged shop schedules dropped by nearly 1/3 compared to the railroad's older EMD units. Reports from Jacksonville and Hamlet described fewer electrical shorts, less time spent tracking down elusive faults, and a growing confidence among shop crews. Mechanics who had braced for trouble found themselves with more time for preventive work and fewer late-night call-outs. For Seaboard, the numbers were impossible to ignore. This so-called cheap locomotive was quietly rewriting the rules of reliability. Fleet analysts tracking locomotive performance in the early 1980s noticed a striking pattern in the numbers. Across major railroads, the GE B23-7 consistently posted an average fleet availability rate of 92%. That meant, on any given day, 92 out of every 100 B23-7s were ready for service. No shop delays, no waiting on parts. By comparison, EMD's GP38-2, the industry standard bearer, averaged 85% availability. The difference might look small on paper, but in a 100-unit fleet, it translated to 7 extra locomotives on the rails each day. For railroad operations, that was the difference between meeting a tight shipping deadline and missing it between a full train and a short one. The data, aggregated by the Association of American Railroads, left little room for argument. Reliability was not just a design promise, it was a measurable, daily advantage that showed up in revenue reports and kept dispatchers' phones quiet. The B23-7's simplicity paid off in more than just maintenance logs. It delivered hard results where it mattered most. A new economic calculus began to take hold in railroad boardrooms. The B23-7 sticker price, about $500,000 per unit, stood in stark contrast to the $650,000 or more typically demanded for a comparable EMD GP38-2. For fleet managers accustomed to equating cost with quality, this gap was hard to ignore. But as maintenance logs and fleet reports accumulated, the numbers told a story that could not be dismissed as a fluke of accounting. Over a standard 20-year service life, the B23-7 proved to be roughly 18% less expensive to own and operate than its EMD rival. These savings were not just theoretical. They showed up in reduced shop hours, lower parts inventories, and fewer expensive overhauls. GE's sales strategists seized on this data, pitching the B23-7 not just as a locomotive, but as a tool for economic survival in an era of deregulation and shrinking margins. The production tally, 535 units built between 1977 and 1984, was not record-breaking, but it was enough to validate GE's approach. The lessons learned from the B23-7's design and cost structure flowed directly into the Dash 8 and later the Evolution series. These successors would go on to redefine the industry, but the foundation was laid by a machine once dismissed as too cheap to matter. Today, manufacturing faces relentless pressure to add features and drive up costs, yet the B23-7's legacy proves that reliability and simplicity can outlast trends and assumptions. As global supply chains strain and budgets tighten, the lesson rings clear. Value is not always found in the most expensive package. Sometimes the smartest solution is the one that just works. What do you think? Does simplicity still win? Share your thoughts below.